19 divided by 42 to give me 0.452. And again, you guys laugh, but again, to type in your calculator, reminder to type in your calculator, you have to type 19 and then the division sign and then 42. Do not put 42 divided by 19. Okay. So again, if you don't have, like I mentioned, if you don't have a decimal, if your answer is bigger than 1, you probably type in the wrong number in your calculator. Okay. So again, question with this thing here. Question with D.
I just have a question about the test. You're gonna say how many decimal places you want always, or is 3 the kind of rule?
On the test, they will on Connect Math, they will tell you how many decimal they want it to be.
Okay.
No, if they don't tell you, just give me 3, and if they tell you it's wrong, just let me know.
Okay.
But mostly they will tell you if they wanted 3, 4, or 2. Basically, they will tell you how many decimal they want to route it. As you can see, the next problem, I don't tell you to route it 3 decimal place, but I keep it 3 decimal place. But again, just if they don't tell you, just keep it 3 decimal place, and then if it's wrong, let me know, and I can go back and give you your point back. Okay. So let's take a look at another one, right? Let's take a look at another one, which is, again, this is all we're doing today, ladies and gentlemen, which is probability after probability after probability, right? So looking at this thing here, which is, again, you look at this thing here, you say, well, what is the difference? Let's say if you look at this thing here and they ask you again, it's the same data. We have 42 students, same as before. And they ask you using the given data to find the following probability. Find the probability that a student, which is one student, is a freshman or a C student. So looking at this thing here, the first thing is you, on your test, on your homework, on your quizzes, you have to ask yourself, well, what is the keyword? The keyword here is the word or. And the word or is, as you will see later, the word or is either mutually exclusive or not mutually exclusive. And I will mention that a little bit later. But this word or tell us that it's a compound statement or a compound event, which is, again, if you look at this thing here, do you agree that this is my freshman and this is my C student, right? So what is the difference between this problem versus the previous problem? If you look at the previous problem, the freshman and the sophomore, they do not intersect, right? You either have a freshman by themselves or a sophomore by themselves. The two category does not intersect, does not cross each other, right? Which is, again, the difference between this one here is, as you can see, I have freshmen going horizontally and C going vertically, meaning they have an intersection, right? I cannot just take 9 plus 10 and divide by 42 like before, because there are some intersection, which is, in this case, let's approach it this way first, and then we will mention about the formula in a bit. So let's approach it this way. Let's take a look at this thing here. Do you agree that this student is a freshman, right? They have an A student, doesn't matter, but it's a freshman. 0, 5, 1, 1. Do you agree that this item that I circled, those are my freshman student? Doesn't matter what grade they have, as long as they fit the freshman, come with me, I take you, right? So do you agree that those are my freshman student? And do you agree that this is my C student, right? So if you take a look at this thing here, which is all we do is we say, okay, you freshmen, take the 2 plus the 0 plus the 5 plus the 1 plus the 1. Those are my freshmen, and then I add the 0, add the 1, and add the 4, which is, everybody see that those numbers that I circle is the number I have here, which is, if I add them up, if I take 2 plus 5 plus 1 plus 1 plus 1 plus 4, I have 14 over 42. And again, 14 over 42, and again, is 0.333333 repeated, right?
So the number in this problem, the intersection, you can't add the 5 twice.
Exactly.
Okay.
Because in reality, you only have 5 students, right? That 5 student is the 5 student who is a freshman and also is a C student, right? So yes, that's the key, and that is a rule for your addition rule for your probability. So this thing here, which is, again, for any 2 event A and B, which is, again, for any two category that they ask you, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B, which is what do they have in common, what do they intersect. So if you're using this formula, which is again, probability of freshman or a C student, right? The first thing is we need to find the probability of the freshman, which is, do you agree the probability of freshman is 9 out of 42? That's what, if you go in there, you select one person, what's the probability of freshman? The probability of freshman is we have 9 freshmen out of 42. Plus, what is the probability of a C student? Well, probability of C student is I have 10 out of 42. But because, like you just mentioned, because of the 5, we count it twice, right? I ask you how many freshmen, you say 9. That 5 you count once. I ask you how many C students, you tell me it's 10, you count that 5 another time. Because you count it twice, because of the intersection count twice, double count, we have to subtract one of them away. And that's what the formula here tells you is we have to subtract one of them away, which is, again, if you add them up, which is 19 minus 5, you still have 14, and 14 divided by 42, you still have 0.3333 regardless. Okay, so again, that's the idea here is in terms of this thing here. In terms of this thing here, the general rule of addition is as long as you have it all, you find the first probability plus the second probability minus what they have in common. If you say, well, wait a minute, Mr. Tran, earlier, let me go back, bear with me here. If you say, wait a minute, Mr. Tran, oh, long way to go. Earlier, right here, why don't you subtract, right? Right here, the freshman or a sophomore, why don't I subtract? Well, as you can see, well, sophomore and freshman doesn't have any intersection, right? They don't overlap. There's no number that I count twice, right? So again, there's no intersection, which is the n is 0. And if I subtract 0, well, I don't really need to subtract 0, right? So again, that's the difference between this problem. Because of the freshman and the sophomore doesn't have any overlap and any intersection, so we don't need to subtract anything, right? Because even if you subtract, you only subtract the 0, which is it doesn't make any difference because you only subtract 0. Okay, so again, that's the formula that we have here. And to make, and again, here come a small rule, the one that we just did, the freshman and the sophomore. So two events are said to be mutually exclusive if the two is impossible to appear at the same time, okay? If both events cannot occur at the same time, then we say that the two events are mutually exclusive, okay? So last time, if you remember your freshman and your sophomore, we cannot pick one student and that student fit both description, right? I don't have one student who fit both a freshman category and a sophomore category. So that will be your mutually exclusive event. And again, mutually exclusive event, all you have to do is find the first probability, the probability of first event plus the probability of second event, and we're done. Okay. So now this is what you have to, and like I mentioned in the beginning of class, this is your objective. This is the hardest part of chapter 4.2 is when you read a problem, you have to ask yourself, is my problem a mutually exclusive event or not mutually exclusive event? If it's mutually exclusive event, I just find the total of the first group plus the total of second group divided by the grand total, which is the overall total. I'm done. If it's not mutually exclusive, I have to find the total of first group plus the total of second group minus what they have in common, okay? So if they have something in common, it's not mutually exclusive. If they don't have anything in common, if they do not overlap or they do not intersect, then they are mutually exclusive, okay? They have that inverse relationship, okay? But again, you can, if they give you this chart, you can look at the chart. Hopefully you can see the chart here and decide if it's, do I just add them up and divide by the total, or do I have to add them up and subtract what they have in common? So you have to ask yourself, do they intersect? Okay, so let's practice, right? Let's throw this thing at you. Same data, just different color, right? So again, same data, given the data, if one student is selected, and again, this one here, if one student is selected at random, find the following probabilities. So again, find the probability of an A student or an F student. So looking at this thing here, you say, well, Mr. Tran, I see the or here, right? That's the first thing. You recognize that this is an or. And one thing I want to point out is when you see the or, you either add them or subtract if they have something in common, okay? Whenever you see the word or, whenever you see the compound item and the word or, is you either add them up, divide by the total, or you add them up and subtract what they have in common and divide by the total. Next time on 4.3, when you see the word and, in 4.3, when you see the word and, it will tell you to multiply, okay? But again, that's the first thing is now you ask yourself, does the A student intersect with the F student, right? And you can see that, again, you either have an A on your test or you have an F on your test. You won't have an A and also an F on the test, right? You might have A on one test and F on the other test, but this is only one test, right? So again, you only have you either have an A or an F, which is in this case, do you agree that this is mutually exclusive, right? Mutually exclusive event, because again, the two items that we're looking for, does not intersect, okay? And again, once you have this thing here, all you need to do is take the 12, add with the 5, right? I have 12 add 5 and divide that to 42, which is 0.405. Someone type in the chat. Yes, right? And again, similarly, if you see this thing here, and again, you say, wait a minute, Mr. Tran, you just told me about the and. And again, because we only select one student, ladies and gentlemen, because we only select one student, it's not multiple time. In 4.3, and when we get to 4.3, I will spread it out again. In 4.3, the word and is multiple time, and if it's multiple time, we will multiply. In this case, do I have a student who is a sophomore and also a D student, which is how many student is a sophomore and also a D student, which is everybody see that I have 3, right? I'm not taking all of the sophomore. I specifically only need a D student who is a sophomore. I do not take all of the D. I specifically take a sophomore who have a D, right? Which is again 3 out of 42. I divide this to get me 0.071. Okay, so again, that's the general idea of probability. What we're looking for, divide by the total. Okay, and again, here come the problem, right? Here come the problem is, what is the probability of a senior or a D student? And again, if you look at the graph, you say, well, my senior item is here, my D student here. Wait a minute, I have something in common, right? I have something in common, which is I have the 2 in common. So again, if I have a 2, that's where they intersect, then I need to subtract the intersection, right? If you don't do this, if you don't take the 11 plus the 7, subtract the 2, and you take the individual number, add them up, you get the same thing, right? If you take the 3, the 2, the 4, the 2, the 0, the 1, the 3, the 1, everybody see that if you take the individual number and add them up, you don't have to subtract the 2. But if you take the total, if you take the 11 total and the 7 total, if you add them up, you have to subtract the 2 because we overcount, right? We double count the 2, okay? So everybody see the difference between port A versus port C. Why on port A, I don't subtract, and why on port C, I subtract. And again, if you can see that, you are in a good shape. If you can see the difference between A versus C, you are in a very good shape. Question? All right, let's try another one, right? Let's say, what is the probability of me select a student, and what is the probability of me select that student? That student is either a junior or an F student. So now, is this a mutually exclusive or not mutually exclusive? Okay, and again, I think on Connect Math, they ask you that question. They ask you, is this event a mutually exclusive event or not a mutually exclusive event? Meaning, if you look at this thing here, you can see that they overlap, right? They intersect. And if they intersect, meaning they have something in common, and if they have something in common, the two events, the junior and an F student, is not mutually exclusive. If they have something in common, they are not mutually exclusive. If they don't have anything in common, then they are mutually exclusive. Okay, so looking at this thing here, we know that because they overlap, we know that we need to, again, if you add this thing up, we have to subtract the 2. And again, this 2 is different than the other 2, right? The other 2 is down here. This is the same where they overlap, which is the 2, which is, again, if you subtract this, add them up and subtract, you get 15 over 42. And 15 over 42 will give you 0.357. So question with this thing here, or question with A, B, C, or D?
Yes, Mr. Chang, I have a question, sir. So whenever given problems like this, will the data always be presented in this manner in a table, or?
I wish. No, there is some on ConnectMath. There is some data to put in this manner. The other, they will tell you, I did not type it here, but the other one, they probably tell you like, what is the probability of you select, let's say they give you a probability of a senior is, let's say 0.2. Let's just make it up, like say the probability of a senior is 0.2, the probability of an A student is 0.3, and the probability of a senior and an A student is 0.1. Let's say that they give you those, which is you have to say that, oh, they give me that there is some senior who is also an A student, right? So again, they will give you the information that either they have it in common or they don't have it common. So some problem they will give you a chart like this. Some other problem you might have to like kind of make your chart yourself, break the chart down, right? They can say, you know, let's say in a class, they will tell you that in the class there are 30 students. 15 of them are male. Well, let's say 17 of them are male. So you have to know that if there are 30, 17 are male, there's 13 is female, right? And then, you know, you have to kind of analyze it that way. I don't think they give you that much of that problem. Most of the other problem is something in this idea of you know, of the table. And the reason why I give you this table, because, you know, hopefully you can see this thing here a little bit easier in terms of the visual, you know, visualize it. Okay, but you know, see if you can do the homework today and then or tonight, and then, you know, whatever problem that you say, oh, hey, I don't understand why this is mutually exclusive or why this is not mutually exclusive, either send me an email or bring it up to class next time.
Okay, thank you.
Okay, so the next question is E, which is again probability of not a junior. What is the probability of me go into this data, select one person, and this person is not a junior? So there are two ways of doing this, which is the first way is, do you agree that my freshman, my sophomore, my senior, those are not a junior category, right? I mean, everybody see that I can ask you, this question is the same as, what is the probability of me going here and select one person, one student, and that student is a freshman, or a sophomore, or a senior? But instead of write all that, instead of write, oh, I want a freshman or a sophomore or a senior, do you agree that I can just say, well, what is the probability of me going here, select one person, and that person is not a junior, right? So again, one way we can do for not a junior is basically we can take whatever not a junior, add them up and divide by the total, right? We take the 9 plus the 10 plus the 11, add them up and divide by 42. Which is, again, we have 30 divided by 42, and I see that we have 0.714, right? So again, that's one way to do it, is we go in and we ask ourselves, well, what is not the category? Because they say not, so we just basically, what does not fit that description, right? So now, the other thing that we have, or the last thing that we have is the complement event, right? If A is an event, the complement of A, which is, again, what is kind of the opposite of A or not A, right? What is not A, which is the not A is basically what left over, right? So this is what they tell you is, if they ask you find the complement of A, then all we need to do is, if we know the probability of A, then the complement of A is basically we take 1 minus that probability. Why 1? because remember, what is the maximum probability? The maximum probability that we can get is 1. The maximum percentage we can have is 100%, and that's why it's 1, right? So again, to find the probability, to find the complement of your event, to find the probability of not the event, all you need to do is take the total probability minus what we have. You know, easy example is, for instance, if you watch the weather channel or watch the weather for today, they say there are 35% chance of rain, right? The probability of rain is 0.35. 35% is 0.35. Now, what is the probability of not rain? Well, if it's 35% will rain, then you take 100 minus 35, you have 65% that is not rain, right? The probability of not going to rain would be 65%, right? So again, that's the idea of the complement, is we take the total minus what we have, okay? So again, if we go back to this thing here, if you attack the problem, then you can take 12 divided by 42, which is, we did 12 divided by 42 is 0.33333 something. If you take 1 minus 0.33333, you will get 0.66667, right? So again, in the sense of that, which is, sorry, what is 12 divided by 42? It should be 296, is it? 12 divided by,
0.285.
what's that?
0.285.
285, 286. Yeah, 0.28.
286.
So again, if you round up, is we get you 0.286, right? So everybody see that if you take 1 minus 0.286, you get 0.47414. That's the 0.714. Right? So again, that's what we have here in that answer, right? So it's just the formula, just a formula, formulative way to doing it, right? Take the total, subtract what we have, what we're looking for, okay? And that's the complement. And the other thing about complement is, if you take the complement,
the complement, I'm sorry, I'm going to interrupt, I want to interrupt you.